are starting into lesson 1.2, part 1. Lesson 1.2 crams, I don't know, way more information in lesson 1.2 than they need to. Okay? We're going to go through a ton of topics. If you notice, I have 1.2 broken into 3 parts. So we're going to break it down into 3 parts. But even with that said, I'm not getting all of part 1 done today. So we're looking at like over a week to get through lesson 1.2. Okay, in total. Okay. Now also, here's another clue. So your lesson 1.1 homework was on page 74, yes? Notice page 92 is where lesson 1.2 homework is. So that's almost 20 pages between homeworks. That's how much stuff is in 1.2. Why they do this to us, I don't know, but that's why I break it into pieces. So, okay, so lesson 1.2 in general is functions and their properties. So we're going to learn a ton of different properties about functions.
If 1.2 is broken into parts, is that also broken into parts?
It is. Yep. And assuming, time works out, we'll check each part as we go. If we run into a, jam up in class or something, we need to hold on to a homework and then check in another day we may. But, yeah. So this 92 2 through 20 evens is what goes with part 1. And part 1 I plan to get through between today and tomorrow. Okay? So yeah, you only have 10 questions to go with this first part because I'm chunking it down. So, okay, so our first main topic and what we're going to spend most of, part 1 is how do we know if something's a function? And those keywords that keep coming back, domain and range. So none of this is new vocabulary. It's all stuff you've done before. It's a matter of how much do we remember? So relearning, remembering, and in some cases taking it to the next level. Okay? So, a function. A function from a set D to a set R, as in from the domain to the range, is a rule that assigns each element in the domain to a unique element in the range. Okay, so if you first remember learning whether or not something's a function back in middle school maybe, okay, each x value pairs with one y value in the range, okay? An x value, basically you were always probably taught the x value can't repeat. That domain value can't pair to 2 different y values. Okay, so that's a function. And we'll talk about a couple of different ways to know if something's a function. Domain. I feel like, have we ever talked about domain this year, or is that my other class? Maybe it's just Algebra 2 we've talked about domain. But domain is officially the set of input values. We also usually refer to domain as the x's. If domain are the x's, then range are your y values, okay, or the set of output values. Now, a couple of things we're going to talk about. So, easiest way to check and see if something's a function. If you have a list of x values, okay, just look at the list of, or x, y values, look at the list of x values, make sure none of the x's repeat. If they do repeat, make sure they each go to their own y's. You want to make sure that you don't have one x value going to more than one y. That's what I want to say. Easiest way to check and see if something's a function, though, if you have a graph. Do you guys remember the vertical line test? We're going to talk about the vertical line test. Vertical line test, you drop a vertical line anywhere you want on a graph, and it's only going to touch that graph in one place. If it crosses a graph in more than one place, then we say it's not a function. Okay, so easiest way to check and see if something's a function, the vertical line test. Vertical line only crosses that function in one place. Sound a little familiar? Okay, so that's a tool to keep in your back pocket there. Now, we're going to spend a lot of time finding domain, and then we'll spend a little time tomorrow finding range. With domain, okay, first of all, if it is a polynomial function, okay, a polynomial function which is just like your x terms added and subtracted. It's like when we talk about parabola, like x squared plus 3x plus 4. That's a polynomial. You can add x cubed minus x squared plus 5. That's, when it's just those x terms raised to positive powers, added or subtracted, those are polynomials. They will always have infinite domains, means they go infinitely left and infinitely right. Okay? A denominator, if a function has a denominator, it can never equal 0. That's something we'll want to talk about. Anytime we see a denominator, we'll want to figure out where it equals 0 because that's a problem in the domain. The inside of a square root must always be greater than or equal to 0, which, in other words, what am I saying? The inside of the square root needs to be positive. Okay? And then the big thing we're going to look at is how we can use the graph to help us interpret the domain. And that if domain is x values go left and right. So we'll talk about reading the graph from left to right to help us find the domain. Okay, so my recommendation as we go through the lesson is that you work to use a combination of the equation and the graph together. Okay, so like being able to physically use the graph is good, but being able to also observe what's going on with the equation, like for instance, is there a denominator that's going to give me an important value, or is there a square root that's going to give me an important value? This will make more sense as we go through examples. That's my recommendation, is being able to look at the equation and look at the graph and combine what you know about the two of them together. Okay? So that's, as we go to talk about domain, that's, some of the things we're going to be looking for there. Okay? Now, we're going to start very basic with example 1. Is y equals x squared a function?
Yes.
Why?
It only crosses through 0. Am I right?
Isn't that 1, 1, or 0, 0, 1, 1, 2, 4?
Oh, never mind. I'm thinking a lot of things.
We do vertical line test. That line that crosses through there one time.
It's a problem, look.
And
Okay.
none of the
It only
x's
crosses through the
repeat,
x
like you write it out.
Okay.
Nope.
Okay, so now, and here's the deal. Yes, it is a function, I agree. But I want to talk about the y's because right here I've heard multiple different options of why we could say it's a function. And you don't have to be able to give me multiple different reasons, but I need you individually to be able to find a reason to support, that we're not just guessing. Okay? Now, so first of all, I would like you to know y equals x squared. This is expected knowledge, and in 1.3 it'll really become expected knowledge. But coming into pre-calc, y equals x squared. You see x squared, your brain says, oh, parabola, yes? That's where I need your brains at. Okay? So if we talk about this being a parabola, then we could talk about a vertical line test, yes? And if we talk about a vertical line test, well, if I drop a vertical line there, it just crosses once. If I drop a vertical line here, it just crosses once. Every place I could possibly drop a vertical line, it's only going to cross once. So is there a reason to say, yes, it is a function?
Yeah.
There's one good supportive reason. Now, do we always know what the graph looks like? No. Do we always have a calculator available to graph it? No, you don't always have that picture of the graph. And so the other topic I want to talk about, there was some talk about XY chart, right? And you don't have to know XY values, but could you think about them? If you put 0 in, you're going to get 0. If we put 1 in, 1 squared is 1. If we put 2 in, we're getting 4. Now, I'm going to hop to negatives. What if I put negative 1 in? You get positive 1. If you put negative 2 in, you get positive 4. But here's the deal. Is there any way that my x values are going to repeat? No. I put an x value in, I get a y value out. Each x value pairs with one y value. Is it okay that my y values repeat? Yeah. That just means it doesn't pass a horizontal line test. I don't care about a horizontal line test right now. Okay? It passes the vertical line test. So for multiple reasons here, I'm going to say yes, it is a function. And yes, Emily, a horizontal line test does eventually become a thing. I saw the look on your face of, what? What is she saying? Okay, it does eventually become a thing, but we're not there. Okay. Are we good with a basic question like that? Now, we could also fall into the category, could we? Wait. Yeah. This is what I would call a polynomial. All basic polynomials are going to be functions. It's a polynomial when it's x terms added and subtracted. They have to have positive powers. We can't talk negative powers. But that's going to fall into a function when it's just x terms like that added and subtracted. Okay, good. Okay, look at example 2. Example 2, the question is, which of the following is not a function?
Third one.
Yeah, the third one is equal.
And why?
Because it goes through the line 3 times.
Okay. This one right here is not a function. I just dropped a vertical line right there. I crossed through it not just once, but 3 times. Okay, so there's the one that's not a function, and my reason is because it fails the vertical line test. Okay? I mean, I don't know, did you guys do like vertical line tests in like middle school? I remember teaching it like 7th grade, you know. So, oh yeah, I'm sure we talked about last year too, but okay. That's very basic function questions there. If they just give you an equation, try and reason through it without the calculator. Okay? But you have an equation, yes? Okay. So, let's move on and talk about domain. Example 3 asks us to find the domain of each of these functions. Now, I'm not going to talk about the graph yet. We will circle back to the graph, but that's not going to be my focal point because it's all too easy to just, oh, let's look at the graph and see what it does. I want to talk about what this is doing without it. Now, find the domain. Domain are what kind of values? X values. Okay, so we are talking about, we're looking at the x values, which x values exist. Okay. First of all, if you look up top, we're talking about finding the domain, yes? It says all polynomials have infinite domains. Well, square root is not part of a polynomial. Okay, it has to be x to whole number powers. And if you remember, a square root is the power of 1/2. So we can't talk fraction powers, we can't talk negative powers. So it doesn't fall into polynomials, so we can't jump to there. Denominators can never equal 0. Do I have any denominator to question? No. The inside of a square root must always be greater than or equal to 0. Do I have a square root to look at? Yeah. Okay. So whatever is underneath that square root, so x plus 3 must be what? It must be greater than or equal to 0. Now, basic solving. How do we solve this for x? Subtract 3 over. And x is greater than or equal to -3. Okay. That right there is at least part of my domain. Okay. When you have a square root, you have to make sure it's greater than or equal to 0. That's going to always be at least part of your domain. Now, in this case, I didn't have a denominator to worry about. The square root is the main deal. This right here represents my domain. With that in mind, Okay, I have my answers in interval notation. Okay. Do you have a thought about what this is going to be in interval notation? If it's x greater than or equal to -3.
It'll be like bracket -3, comma, infinity.
Mhm.
With a parenthesis.
Does that sound familiar? Okay. Now, so greater than or equal to -3 says it starts at -3, equal to, we're going to use a bracket, comma, going infinitely right is infinity. Infinities always use parentheses. Now, could the graph have helped me? Because I'll be honest, we just finished this problem. Okay? I mean, I'm still going to write a few more things up here, but I don't know, did anyone look at the graph before I said I'm not looking at the graph yet?
Yeah.
Yeah.
That's fine, that's fine. Does my answer make sense with the graph?
Yeah.
Okay? So when we talk about reading the domain on a graph, x values run left and right. I'm always going to tell you to start left and work your way right. If I start left, where is the first time my graph exists?
That's -3.
And it looks like -3. Does it make sense it would be -3?
Yeah.
Yeah. If you hop on here to trace, okay, I just hit trace and I'm just arrowing over. It's probably not going to come up exactly -3, but notice at -3.03 my y value fails to exist. At -2.87 I have a y value. So where did that graph probably begin? At -3. Or, I don't know if you remember anything from Algebra 2. Do you guys remember graphing square root functions?
Yeah.
And moving them left or right? In order to move something left or right, it's the number added or subtracted from the x in the square root value, and you go opposite the sign. So a +3 would take this graph where?
Left.
Left 3. Am I pulling back some algebra stuff here?
Yeah.
I'm trying. Okay. So for that reason, you could also take a peek at the graph. And that graph should reassure you. Okay? Because what we're looking at here is my graph starts at -3, right? And it goes infinitely to the right, yes? It starts at -3, it's going infinitely to the right. So when we talk about finding the domain, I always say that we read our x values from left to right. And we talked about that in algebra last year. That's not new to you guys, because I've already taught that to my Algebra 2 kids this year. Domain is left and right. You just read left to right. What I'm trying to get you guys to do is find the happy medium of sometimes we have a graph, sometimes we just have an equation. Questions I should answer or address there? And the hardest part is when you have to do it on your own. So, you know, it's easier when I'm leading you. Okay. Officially, we'll talk about B tomorrow, but before I let you go, just while the things are fresh in your head, based on that list of items up above, what are concerns that we're going to have to talk about in B tomorrow?
Number 2, denominator.
Okay. There's a denominator, yes? We need to figure out where that denominator could equal 0 because my graph won't exist. And what else? There's a square root. A square root has to be greater than or equal to 0. It has to be positive. So we're going to work hand in hand, and there's going to be a little bit more going on with this graph. Okay? And eventually we'll look at the graph, but right now I'm just trying to get you guys to look at the equation. So remember those. We'll talk about those two things tomorrow. Okay?